Alright folks, so in this video what I wanted to talk about is what is context engineering for AI agents. So let's first talk about what this context engineering is. So just to give you some assurance that this is nothing new with this, we have been doing, like we have a lot of videos in this channels like how to build an optimal agent. So whatever the techniques that we have been using in the past few videos or past few talks about the agent, so everything like building a agentic RAG, or you use a LangGraph, right? So there you use the state mechanism to store the intermediate nodes output, and then you have a history, right? So and the optimal prompt engineering, like you give clear system instructions in the while creating the agents. So all that are part of context engineering. Not only that, like you can generate a structured output from an agent node which can be used for a subsequent agent nodes for performing the optimal task, right? And also we kind of integrate memory, so that can be long-term memory or short-term memory, so that we can also integrate to the agent. So all these concepts that we have been doing so far, that's what we call as a whole as context engineering, right? So this actually got famous with some definition that is coming from Andrej Karpathy, where he kind of mentioned that so LLM is kind of a new operating system that we have, where the LLM acts as a CPU and the context is acting as a RAM, right? But also what we have seen from those discussion, that just like RAM, the LLM context window also has limited capacity to handle various sources of context, right? So you can see, like if you are having a low RAM system and if you're trying to do heavy lifting task in your laptop, so that time the laptop gets crashed or it takes a lot of time to complete that task, right? So similarly, if you are putting a lot of context that can exceed the context limitations of the underlying LLM, so that can degrade the performance of your agent, right? So that's what we are trying to solve by doing optimal context engineering. We try to improve the performance of your agent, right? And the Karpathy kind of given us a definition of this context engineering, where he kind of mentioned that context engineering is the delicate art and science of filling the context window with just the right information for the next step. So now let's break down what are the types of context we have for LLM. So you can see some of them are like instructions, knowledge, and tools. So just to let you know whatever the screenshots and whatever the discussions that I am going through in this video, so the credit goes to the LangChain blog post where they kind of discussed what context engineering is for AI agents, right? So now the instructions are nothing but the prompts, memories, or the few short examples, or the tool descriptions that we generally have whenever we are building an agent, right? Now the knowledge is nothing but the facts and memories, and the tools are nothing but the feedback from the tool calls, right? So generally we kind of augment the LLM with a lot of tools in case of agents. So that's where we also get the response after doing a tool call. So that's where the context can also come from the feedback from the tool calls, right? So these are the typical three types of context that we would be dealing whenever we are trying to do the context engineering for AI agent. Now if I talk about the architecture of agent, so agent, the basic building block is a centralized LLM where we kind of pass a prompt, so that prompt goes to the LLM and we kind of augment the LLM with certain external tools, right? So those tools can be API, database, memories, or even a vector DB, right? And this with this augmented tools, the LLM kind of decides based on the given prompt like which tool I should select. So this selection process goes on for a certain period or in a certain loop till the LLM kind of decides that now I have done all the steps to generate the final response, right? So this is what we typically have whenever we are building a AI agent. So and this you can see looking at this diagram and whatever I have mentioned, that this looping process can go on for a certain time till the LLM kind of thinks that now I have done all the steps to generate the final response, right? So this agent kind of goes through a series of LLM and tool calls, which in turn kind of utilizes a large number of tokens, and that also kind of increases the size of the context, right? So that size can sometimes go beyond the context length of your LLM, right? So now with this understanding, let's discuss why we need context engineering. So one of the reason, as I was mentioning, that sometimes this repeated LLM and tool calls can exceed the size of the context window, which can be a problem, and that time your AI agent will throw kind of error. So another reason is that, as we are seeing, that it should go through a lot of repeated tool calls and LLM calls. That can also increase your latency of your generative AI system if you are following an agentic approach, right? Then if you are having a large context which you are passing to the LLM for doing the decision making, so then there is a phenomena called lost in the middle. So if you give a context to LLM, so LLM kind of only uses the starting portion of that context to generate the response, instead of looking at the middle and the last portion of the context, right? So that's what we call as lost in the middle. So the last portion of the context can carry very valuable information. So if you are giving a huge volume of context, so LLM can get lost in the middle, and those valuable informations which can be present at the last, that can be lost, right? So just to avoid this three scenarios, we typically need the context engineering. Now let's run through the ways where the context can get out of hand, and which can also kind of degrades the performance of the agent, right? So one of them is the context poisoning, where we face the problem of hallucination, where the wrong context has been provided given a particular question, and using that wrong context or hallucinated context, the LLM kind of generates the wrong response, or the agent kind of generates the wrong response, right? So then we have the concept of context distraction, where you can use a fine-tuned LLM, right? And if you are giving a very large context to that LLM, so then what can happen is that whenever the context grows so long, that the model or the fine-tuned model over focuses on the context, neglecting what is learned during the training process, right? So for the purpose for which you kind of fine-tune the LLM, so that can be lost. So model's own behavior for which the model was trained, it can forget that, and it can give more emphasis on the context instead of for the task for which the model was fine-tuned, right? So that's what we call as context distraction. Then we have the context confusion, where we have like unnecessary content in the context which is used by the model to generate a low quality response, right? So here we are kind of giving wrong information in the context itself, and using that LLM or the agent kind of generating the wrong response, and the model or the agent is kind of getting confused with this unnecessary content that is present in the context. So that's what we call as context confusion. Then we have the context clash, right? So when you acquire new information and tool calls in your context, that kind of conflicts with the other information that is present in the context, right? So in the context itself, you are having like self-contradictory informations through which the model can get confused, and in turn the agent kind of gets confused, and it can generate wrong response, right? So these are the some of the scenarios where you can face that, where the agent is performing very poorly, and that can be either due to the context poisoning, distraction, confusion, or the context clash, right? So that's what we are trying to avoid whenever we are trying to do the context engineering, right? So now let's talk about what are the strategies to do better context engineering. So LangChain kind of given us this 4 strategies which we will discuss now in detail, right? So first one is a right context. Right context means that we are saving the context or the valuable information outside the context window of your agent to help agent perform a certain task, right? So this can be of 2 types. So this can be within the agent sessions, and it can be also outside the agent sessions. So let's first talk about within agent sessions. So we human beings also take notes, where we can, whenever we are learning something, on whenever we are going through a certain tutorials, we take notes. Similarly, the agents can also take notes within the current session for future use, right? So other one is a state. So if you have gone through a lot of videos in this channel about LangGraph, so LangGraph uses this concept of state, where the intermediate node outputs you can save it in the state variable. Whenever you need it in the future use, you can go to the state and pull out the critical information from the state, right? So that's what help you to do the task in a much more better way. So then there is outside current agent sessions, where you can store the memory in outside system like LangMem. Whenever required, you can do certain techniques through which those informations which are stored outside the current agent session, that can be pulled and that can be used in while generating the agent response, right? So one of the technique is that you have an existing memory, then you get the new content, right? So that you pass to LLM to generate new updated memory, and that you can also write down to the memory store, right? So then we have the select context. So selecting context means pulling it into the context window to help the agent perform a certain task, right? So the agent is going through a trajectory. Sometimes you need to pull the correct information or the correct context from certain areas so that the agent can perform the task in a much more optimal way, right? So whatever we have discussed, right, the scratchpad or the state, there you can previously you can store the informations, and whenever required you can put certain mechanism through which you can pull the informations either using a scratchpad or a state variable, and based on that the agent can do the task in a much more better way, right? So then we have memories. So these memories can be of several types: the semantic memory, episodic memory, and the procedural memory. So in case of semantic memory, we try to bring the facts, like a fact about a user, right? So then we have the episodic memory, where we try to bring the experiences or the previous past agent actions that the agent goes through during its past trajectory execution, that we can bring and that we can pull through using the episodic memory. Then we have the procedural memory, where we have the instructions, which can be an agent system prompt, right? So based on a certain task, you might need to pull certain system prompt where you can change the behavior of the agent to get more optimal result, right? So this typically this type of memories, we can use a tool like LangMem, where we have semantic, episodic, and procedural memory, and through which you can implement these strategies, right? So then we have a few other components through which you can select the context, which is like tool selection. So whenever you are augmenting the LLM with a lot of tools, right? So with a lot of tools, the agent can be overloaded, and with a lot of tools, the agent performance in terms of correct tool selection can also be degraded, right? So you can use a tool like LangGraph Big Tool, where we kind of create a rack system where we kind of give the tool name along with the description of that tool, and that we store in the memory, so that whenever agent needs to do a tool call using a semantic search, it can pick up the more optimal tool to do the task in a much more better way, right? So in this channel, I have previously released a video in using this LangGraph Big Tool, so that you can go through to understand how you can do a more better tool call whenever you are augmenting the LLM with a lot of tools, right? So the other technique which you can use, that we can select the context using the knowledge store, right? So RAG is one of the popular ways through which we kind of get access to the proprietary data, and you can use certain advanced RAGs to fetch the better context using this vector DBs, right? So knowledge graph using graph based techniques is getting so much popular nowadays. So in a graph database, where the entity and the relationship has been stored in the graph database, and based on that you can do more optimal retrieval using this knowledge graphs, right? So re-ranking is another technique which you can implement whenever you are pulling a context, like you have fetched 4 contexts from the vector DB, right? So then you can perform the re-rank to get the more relevant content at the starting. This is again to avoid the lost in the middle problem. So using this technique, so you can do the better selection of the context, right? So then we have this concept of compressing context. So compressing context involves retaining only the tokens that are required to perform a certain task, right? So you will throw away the unnecessary informations or the tokens from the current context window, and you will only retain which are relevant to the current task, right? So one of the way you can do it is a context summarization. So you can see that typically this agent goes through a lot of steps, right? So it can get feedback, then it will do a tool call, then again it will get a tool call feedback, then it will get a human message input or a system message, right? So all that can be part of a history. So all this history you can pass it through a LLM, and then you can do a summarization So this context summarization is one of the way through which you can reduce the unnecessary tokens from the current context. So this agent interactions that can span like hundreds of turns, and it can be increasing the current context window with lot of tool calls and a lot of LLM calls, and also the human and AI message inputs, right? So you can do the summarization whenever the current context is kind of going past above the 95% of the context length, right? So this is just for an example, like if the context window is reaching to a limit of 95% of the context length, then you can pass all this information through LLM, and you can summarize the historical inputs that we have, right? So then you can also summarize the tool call feedback. So tool call generally gives a lot of feedback, and it can increase the size of the current context length, so that you can pass it through a summarizer and you can get a smaller tool call feedback, right? So then you can use it in the current context, right? So context summarization is one of the way. Then the other way is the context trimming, right? So whereas the context summarization typically uses an LLM to reduce the size of the context, so trimming can often filter out, remove redundant pieces of the history, or it can also remove the older chat history or the function calling outputs in the current agent trajectory, right? So one of the example that you can use a model like Province, so where given a context and given a question, it can reduce the size of the context by 95%, and it can only leave with the content that is only relevant to the current given question or the current given step, right? So this will reduce the size of the context, and you can trim out the unnecessary piece of the information that is present in the current context, right? So the other one which we typically use so is the isolating context, right? So isolating context involves splitting the context so that the agent can perform the task in a more optimal way with the separate set of context, right? So one of the popular way is that you can use a multi-agent architecture, where like you can have sub agents which can operate in parallel with their own context window, and it can keep on doing its own task with a separate set of questions simultaneously, right? So you can see like we will have a supervisor, and then we can have two agents, and these individual agents will have their own context window, and there these agents can perform simultaneously using their own context window, and once that task is done, then it can send the feedback to the supervisor. Then the supervisor can decide which would be the next step to take based on this individual inputs. So in that way, as this sub agents are operating simultaneously, and it has its own context window, so the performance degradation would be much lesser because these agents are performing in their own way, right? So the other way you can do context isolation is that you can use a code agent. So Hugging Face released their own code agent, which is small agents. So you can see that the agent will generate a code, so that code needs to be executed, but that code will execute in a separate execution environment, right? So there the whatever the objects that the code execution part is generating, that is not getting integrated to the agent's context window, right? So you are kind of isolating those code execution outputs or inputs in a separate sandbox, so that is remaining in isolation, and based on that the current agent's context is not getting flooded with a lot of informations, right? So there, using this concept, you can isolate a context which can reside in a separate sandbox, and the agents can perform in a much better way to generate the better response, right? So these are some of the ways through which you can do optimal context engineering. With this, I will end this video. I will see you in the next one. Thank you.